On Thursday, March 17th, Radeon gamers everywhere rejoice as all of their games can now be played at higher frame rates. With the compromise to image quality, what am I talking about? Is it FSR 2.0? Actually, no, but we got a lot of news about that as well. We also have news about RSR finally releasing. And let's talk about that, because my last video with this slide and talking about FSR 2.0, there's a lot of comments where some people were confused about what is the difference between RSR and FSR 2.0, and that happens to fit perfectly into today's news. So jumping down here, the main information I have for you is leaked AMD slides from AMD that video cards got their hands on ahead of time. Now, there's some really interesting stuff, including claims that FSR 2.0 will look better than native resolution in certain situations. I've got a lot of thoughts about what they actually mean about that. Don't get too excited. But once again, they also had some information about RSR. And the RSR update, that's the Radeon Super Resolution, which is not the same thing, is actually launching March 17th. So basically, there's a slide, or a set of slides, that video cards got their hands on that is supposed to be launched on March 17th. In these slides, RSR is released, and FSR 2.0 is officially announced, with some details given, but further details to come at GDC 2022 next week. That is next week, right? Yeah, I think so. Anyway, or a week and a half, something like that. March 24th, I think is the deal. But anyway, let's first dig into what's the difference between RSR and FSR 2.0. So RSR is basically doing something similar to what people have already done with FSR 1.0, which is there's apps like Magpie and lossless scaling that I've even reviewed and demonstrated on this channel that take FSR 1.0's upscaling algorithm, because that was released open source, and then just apply it to pretty much any window. And then you're using FSR sort of on that game. If it's, for example, a game that you're running in like a small borderless window, and then it upscales to your monitor's native resolution. RSR is AMD's official version of that through their driver. And to be clear, this is not FSR 2.0. In fact, it should look worse than FSR 1.0 because RSR is applied at the end of the rendering process, whereas FSR 1.0, when it's officially built into a game, gets applied near the end of the rendering process, but certain post-processing effects and menu elements and HUD elements actually still get rendered at the game's native resolution rather than upscaled. RSR is going to be a driver-level implementation that just applies it to the final image of the game, including post-processing effects. So like film grains sometimes look bad when you do this through something like lossless scaling or Magpie. That should also be the case here. And again, your menus and things won't look quite as crisp. Now, what it will do is get you significantly better frame rates in basically any game. As far as I know, this should support almost any game through the driver, but I'll definitely be testing it out on the channel, absolutely, when it comes out. Okay, so what is FSR 2.0 and what do we actually know about it? Well, notice the headline here, temporal upscaling, but let's get into the actual slide that video cards seems to have their hands on early. So here's what they have. They have that it delivers similar or better than native, right, or better than native image quality using temporal data and includes optimized anti-aliasing. Let's dig into that first bullet point here for a second. So what do I think that means? Well, first of all, the big deal here is temporal data. And what that means is that this is a TAA upscaler, or at least it kind of is. But then they have their optimized anti-aliasing. So FSR 1.0 requires, basically uses the anti-aliasing that the game already has. And some games have good anti-aliasing and some games don't. So honestly, in a lot of situations, if we compare this to DLSS, in a lot of situations where people claim that DLSS looks better than native, it's because DLSS has its own anti-aliasing, which is sometimes better than the game's default anti-aliasing. So when you run the game with DLSS, sometimes because the anti-aliasing looks better than what was originally in the game, your output upscaled image has certain elements to it that do look better than the native image, which was using the game's built-in anti-aliasing. So I think that's what's really going on here. I don't think it's that this is going to be able to reconstruct a better than native image. I think that it has its own anti-aliasing, which could be better than the built-in anti-aliasing in a game and have a similar effect to what DLSS 2.0 and better has done. So I think that's what's going on with that. Now, this temporal data actually has a big downside as well. I think that means that like doing something like RSR is, where RSR can just be applied at the driver level to any game, I don't think that we're going to be able to do that with FSR 2.0 because it's going to require, the temporal data, motion vectors, that kind of stuff, most likely from the game itself. And so it probably needs more of a actually being built into the game engine or, closer work with the developers for this to actually work, more like DLSS. Now, they are definitely claiming that this produces higher image quality than FSR 1.0 at all quality presets and resolutions. And here's a big one, does not require dedicated machine learning hardware. And boosts frame rates in supported games across a wide range of products and platforms, both AMD and competitors. And then asterisks here. Okay, so wait, what is all this? Well, let's jump back here for a second. Does not require dedicated machine learning hardware. So this is a big question mark. So does that mean it's something like XeSS does, where it has some machine learning, upscaling and acceleration on Intel hardware, but then has a DP4A fallback to support other hardware? Question mark. Or does that mean that this is really not much machine learning involved here at all? Is it really just a temporal upscaling? In other words, is this actually going to be any better than what we see in like Unreal Engine 4 when you just have your resolution slider and it uses a temporal upscaler? How would this compare to the TAAU in Unreal Engine 5? Well, honestly, TAAU in Unreal Engine 5 looks really good. So if this is just something like that then could be put into into other games easily, maybe AMD can partner with developers to get it into their engines, question mark. I don't know. So that then brings up the question of how well will this compare to DLSS, which does use the dedicated machine learning hardware. And again, this says it doesn't require dedicated machine learning hardware. So again, does that mean it could be accelerated by that? Maybe RDNA 3 has some kind of dedicated machine learning hardware and gets a bigger performance boost, but then this just supports older ones on fallbacks. This is a big question mark. And again, boost frame rates in supported games, right? In supported games. So this is definitely not like RSR where you just do this in everything. Across a wide range of products and platforms, both AMD and competitors. Now that last bit is kind of a big deal. Now another thing that we get here is we get this little bit. 4K native resolution with ray tracing, 53 FPS, FSR 2.0 on, performance mode with RT, 101 FPS. So we're doubling the frame rate with ray tracing on. Now we don't know what game this is, although if you read the video cards article, they do talk a bit about Deathloop specifically, although it's unclear if this is specifically from Deathloop. But that could be one of the initial supported games, and that could be this slide, although we don't have an idea what this GPU is. Although if it was getting 53 FPS at 4K with some ray tracing on, I'm guessing this was at least a 6800 XT, if not a 6900 XT. I doubt we'd see any performance numbers from RDNA 3 yet on a March 17th announcement here about the upscaling technique. So I would assume we're at most doing a 6900 XT, maybe 6950. Those are coming out soon, but I don't think they're officially announcing that at the same point anyway. But anyway, so there's that. And now notice that is the performance mode. Now performance mode in FSR 1.0 looks like garbage. It's an oil painting. It looks nothing like the native resolution. would this performance mode actually be worthwhile at 4K with the 2.0? That's the big question mark. I really hope so. That would be very cool. Now, the video cards article, I don't think has a whole lot else other than what I just kind of went over to with you on that. Other again, that this is just a teaser for the GDC 2022 session on March 23rd. And so I think we're going to get a lot more information at that point in time. Also, when it comes to RSR, we are seeing this is going to be 5,000 plus, RX 5,000 plus GPUs. So that kind of sucks. I'm not sure why it would have to be only 5,000 and up. Why can't your RX 580 support it? I'm hoping that that will be updated in the future. In the meantime, if you're disappointed by that, I would say, look into your lossless scaling and MagPi type apps to apply FSR in a very similar manner to what I think RSR will be doing in the through the driver. I'm gonna hopefully have time to do a comparison of RSR to like lossless scaling and or MagPi to compare if there's pros and cons to doing it through the actual driver in terms of performance and or image quality. I am so excited for all of this, guys, but I also need to get to work. So I'm gonna let you guys go and have an excellent day.